today. This is the Kentucky Center for Mathematics. We are a group out of Northern Kentucky University. Our sole core value is that we are looking to support teachers from across the state, the Commonwealth of Kentucky, but even that across the nation. And then today, it seems as though we're across the world. So that's exciting. I'm going to turn it over to Cindy. She has a beautiful presentation for us. Always feel free to chat in the chat box and unmute yourself to ask some questions. Today is a day of growing and learning. Cindy, thanks for taking the lead today.
My pleasure. I'm excited to be here. Welcome, everybody. How awesome to see so many familiar names and so many new names. I do have the text chat up, so that's a good way to kind of interact during the meeting, or just unmute and shout out, because I admit I don't have access to everybody's visual here. We are going to start our week of middle school work, thinking about fractions and decimals and some open-ended problems that we can use to engage students in thinking about addition and subtraction. Also still be learning to use Zoom here, so if we have any technical difficulties, please let me know. Here's my contact information. You do have access to this PowerPoint, and that'll continue to be available afterwards. So please feel free to reach out to me, ask questions. Would love to hear from you, or even just share how it's going and things that you're trying, or just if there's needs going forward that we can plan for in future events. So we'd love to hear from you. We are the Kentucky Center for Mathematics. We work statewide. Just a little bit of a snapshot here of some of the work we do, courses, and working with 73 cohorts of teachers. That's over 1,000 teachers that we've worked with in person. We are now transitioning to providing that support and interaction online, like all of you are. So we are so excited to have you here today. Also, our website, please feel free to reach out to us there. And that's where you'll also get links for our future meetings, but you'll also find links from our elementary meetings last week with the recordings and with the PowerPoints. And so those show up on our homepage, and you can just click through and find all those great resources. So as I was thinking about what we wanted to do today, I wanted us to do math. I think we teach mathematics because we have a personal love for it, and it's fun to do together. So I wanted to give us a chance to do some problems and share our thinking and have those conversations, because there's just a joy and comfort in that we want our students to experience. And I think it's good sometimes for us to have that opportunity as a participant to experience it. Also, I wanted to play around with finding tasks and resources that we thought would be useful to you. Things that would be problems you might want to pose with your kids, resources that you might want to use with your students, and felt it was important that those would have multiple entry points for your students and would have lots of room for them to play and experiment, to try something else, and also that they were what I'm thinking of as remote teaching friendly. Problems that would be fairly easy to pose to your students. And so part of what we're doing today is just kind of figuring out options for how to engage students in that mathematics. So those were some of my goals as I was picking out problems today. So the agenda for that, snapshot of the research as we launch this week of middle school work, thinking about which standards this particular session will address. And then the tasks. We're going to do some tasks from Open Middle, which may be familiar to you already. If so, we'll hope you'll share some of your experiences with using it. But also we'll engage a little bit on how we might use it in remote teaching. Also tiled area questions. And of course, we're better together, Team KCM. So for the research, I'm touching back on some work by Susan Lamont in her book, Teaching Fractions and Ratios for Understanding. And what we know is this is very hard. I've seen statistics that up to maybe 90% of our population doesn't actually reason proportionally. So we have some struggle here, and we need for our population to have a sense of scale of numbers and how numbers interact. I think we've been seeing evidence of that these last few weeks, of how critical it is that people understand enough mathematics to really understand what's happening as we make projections and everything that's been going on in our real world. So where does some of that start? Well, one is, what is the meaning of fractions? So we think about understanding rational numbers, and proportional reasoning. And proportional reasoning lives in those relationships between numbers. And so Susan Lamont has identified these categories, these core ideas that students need to engage in over multiple years. It starts in upper elementary, but continues all through middle school, and I would say well into high school, that students should be engaging with these deep concepts. And so there's an awful lot going on in this web, but I do like that she uses that web imagery, because it really speaks to how building in one will support and build and make connections to another. So these aren't standalone, they're not a sequence, but they're interconnected ideas that students deepen their understanding in one, and then take that understanding to deepen another, and so on and so forth. Today, we're going to live primarily in that upper left-hand corner. We're going to dig into some of that measurement meaning and be working with those fractions. So thinking about even what that symbol A over B, what does it mean? And we'll have a hint of some of that reasoning up and down. Throughout the week, we'll get into much more of these. And then I wanted to share, some of you are familiar with that resource by Susan Lamont, and I was so excited as I was pulling my screen captures for the PowerPoint that I realized she has a new book coming out. So the 4th edition, not brand new book, but the 4th edition of her work. And so I wanted to share, you'll have in that PowerPoint the link for her new book that's coming out on the 7th, new edition, I should say. So for standards, we actually are going to pick up in the 5th grade. We're going to be thinking about the fractions and how 5th grade students are adding and subtraction fractions and mixed numbers with unlike denominators. And one of the things I love about this particular standard is the emphasis that it's more than the procedure of finding common denominators, but really we need students to understand why fractions get added the way they do. And they can visualize that maybe on a number line, maybe using kind of a fraction pieces, sort of a linear bar model, maybe C-rods, and they understand it as finding a quantity, that counting. And then also in 6th grade, we're continuing to develop that fluency. We know kids are using their knowledge of adding and subtraction fractions, and often find that could be a stumbling block in 6th and 7th grade, that when students don't have those understandings, it's a barrier. So we know we continue to work on those well into the middle school years, and also take that to working with decimals and being able to formalize that process. So open middle task. These are one of my favorite kind of prompts to give. Lots of options to it. And I'm going to ask you to solve this one. So just take what time you need. The task is, I'm going to ask you to fill in digits into those boxes. So use the digits 1 to 9 at most once each time to make an equation that is true. And so I hope you have your scratch paper with you. Please grab that if you don't, and start jotting down an equation that you think might work in this. And if you find one, find another, find another. And I'm going to give you some time here, some quiet to think about that. And then in a moment, I'll ask you to type that into the text chat. But I'm going to ask you to hold off in just a moment and give everybody that think time. If you have any questions about the task, please go ahead and type those in, or unmute and ask about that, please. So as you're finding an equation, if you're willing to share it, go ahead and just type that into the chat. And I'd also invite you to add that with a very short couple word explanation that kind of hints at how you approach the problem. maybe just where you started, like what number did you fill in first? Maybe something that you tried and then fixed to get that answer. You know, so something that maybe you tried didn't work, but then you fixed it to make it work. But go ahead and just start sharing some of those ideas in your text chat.
You want it in text?
Yeah, go ahead and do it in the chat of the Zoom. And share those with everyone, and then you can also start seeing what other people are trying. So we're going to continue talking about this problem. So please feel free to continue adding those ideas to the chat. We're seeing some great ideas. I wanted to point out this recording sheet. So if you've used Open Middle before, you may have seen this, but if not, know that this is available on the Open Middle site, and I'm going to show you in a moment where to get it. It's also in the printable packets for this session. But I share because the nice thing about this document is it really shows for you how these problems we want students to be trying multiple times. And even that language of attempt, we want them to try something. And if it doesn't work, why didn't it work? And what are you going to do to fix it? Or if it does work, is there another one that'll work? And how does your strategy evolve? And there's little places in there to score if you were to score. It's really not about assigning a score, but it's just sort of a way to communicating to students that what we value is your attempts and your reflection, your attempts and your reflections, the ways you're refining and expanding. So you guys are already coming up with these amazingly different answers, and we're going to go ahead and pull some of those out. And that's where the discussion piece comes in. Some of, depending on your students and what grade levels you're in, you may want a visual to go with it, in which case an app like this can be really handy. It does require Flash, so I know that can be a limiting factor in some cases, so be sure that you check that the app will work for you. If that's, if you're going to give it to students, be sure that that'll work for them. But I think it'll work for us with what we want to do now. It has some fraction bars in there, so we could use those to model. It also has decimals, and those are scaled and equivalent, which is really nice. And it also has percents. So it's a fairly versatile app, and it's also going to let us do some handwritten recording. So I'm seeing several different strategies in here and approaches. And I had one or two that matched my initial, and Jacqueline, I think. I'm going to ask you if you don't mind, and if you don't, that's fine, just tell us in the chat. But I saw your answer, and I was wondering if you could go ahead and start us off by sharing how you got to yours.
Okay, so I did a problem. I'm not sure which one you wanted me to share.
Oh, the half plus 3/6.
Okay, so I knew that a half plus a half would give me one whole. So I just needed to find halves that used 4 different digits there. So I did 1/2. And at first I was really just wanting to do 2/4, but I realized that would work. So I went with 3/6. But I could have obviously used a whole bunch of other things like 4/8 and 1/2 would have also worked. So like that just was kind of my thinking was, I know the answer, how can I get 2 fractions that'll equal that? And that's also kind of what I did with my whole number too, when I did another whole number.
Okay, we'll come back to that one in a minute, and because I think I know which one you mean. So, so some students, and several of you did, started with some idea of, well, I know if I'm making one whole, I can decompose that into 1/2 and 1/2, but that breaks the rules, right? I can't use the 1/2, I can't use the 1/2. And so you start playing with what are different ways to express that 1/2. So one of them, Jacqueline, you said you came up with this 3/6.
Yes.
Now we do run into, we're not allowed to reuse digits. So we still can't use the 1/2 either. So you mentioned that you did have some other options, or Lisa, I think you had an option there.
I did +4/8.
And so then do we satisfy our rules? Because we used a different digit and everything. So we had this idea of equivalence coming out, right? I want to think about how can I make the 1/2. Ooh, that's a badly spelled equivalence. Please have mercy on me. And we had this idea of decomposing. So I just wanted to take a moment as a teacher and just sort of name, like, what's the kind of thinking we hope kids come out of this? And we're already seeing some really nice mathematical ideas coming out of what is a fairly simple prompt on the surface. Okay, I'm going to clear that board. And I'm going to scroll back up in this chat, and I'm going to pick on somebody else. And Mei Ling, if you have a microphone, I'm going to write up what your task, what you chose up here, and if you wanted to go ahead and tell us more about it, I'd love for you to do that.
Hello, can you hear me?
I can, and thank you so much for being willing to share.
I think what I was doing was similar to Jacqueline. I started with the whole number 1, and I knew I had to add 2 halves without using the 1. So I just thought of 2 equivalent fractions that could add up to 1.
Okay, you're right. I did see that. Awesome. Thank you. And then, oh, where's the one? I think my text box scrolled on me. Kesties. Let me go ahead and get that one up here. And that was, sorry. It's a learning curve for all of us, isn't it, here? You have a microphone. I don't know if you do.
I do.
Go ahead. Will you tell us a little bit about your thinking?
Yes. So this is Kim Estes.
Oh, there we go.
Yeah. So I noticed that the box at the end for the answer was just one box. So I thought, okay, so I need a whole number answer. And so I started first with 1/2 and thought about thinking of other fractions to give me 1/2. And then I thought, well, the whole number doesn't have to be a 1. It can be any whole number. And so that's where my thinking went to. So let's just switch the 1/2 to 2/1. And so then I just started playing around with some fractions greater than 1 using different digits to give me another whole number answer with a digit that I hadn't used.
And by the way, it's very nice to hear your voice. It's been a while.
You too, Cindy. It's great seeing you.
So yeah, we started, somebody even talked about in the text box, talking about using those improper fraction forms or top-heavy fractions or just simply fractions, fraction form. And so we want kids to be very, very comfortable expressing quantities. You know, that 2 is 2/1. It can also be expressed as 6/3. And 6 or 6/3, perhaps better to say it that way, but have kids be very comfortable that this is a legal way to express the quantity too. We want kids to be very comfortable with fractions written in that form. And we could continue with this. This was a fairly simple prompt. And what I hope you saw was we already saw equivalence and of course addition of fractions and decomposing a whole. We saw strategies of starting with a number.
What if they close grocery stores and we have to hunt for our food?
And getting to the next whole, and all sorts of options in a task that we could really just do with a screenshot through a remind text and encourage kids to find, you know, 5 different ways to solve this, and then start maybe finding some way on a asynchronous board discussion forum to share it out, or having kids send back your ideas and you have some way to then disseminate that to the group, or even assign them a talk partner in some way of call a friend and see if you guys found different ways or are the same ways. So finding some ways to reincorporate that discourse back when this remote learning might make that a little challenging, legitimately so. Okay, we're going to go ahead. I'm going to give you another one, and we'll kind of pick and choose how much time we spend on it, but I want you to do the math. And again, when you have an idea, I'm going to go ahead and ask you to pause and not type anything yet, because we want to give everybody think time. Same idea as last time. We're going to use the digits 1 through 9 at most once to fill it in to make an equation true. But I want you to notice we have an additional goal of also making that sum as close to 10 as possible. So play with that and think about how you can make it both true and make that sum as close to 10 as possible. And now I'll go ahead and say, if you do have a solution, feel free to type that into your chat. And if you can capture in a few words your strategy, please, I'd love for you to add that as well.
Hey, Cindy, can I ask a clarifying question?
Please.
So if I'm using the 10, I don't know if you can see this. If I'm using the 10 as what my sum is, can I not use 1 again?
But it has to be in the form that's shown here. So it has to be, you are limited. So in this case, we're not going to be able to make 10 because that won't fit our form.
Okay, that answers my question. Thank you.
Perfect. So we're starting to find it gets a little more challenging. And these prompts, we're going to take you to the website and you're going to see this amazing bank of prompts like this, range from something that's pretty quick, like the first one, to, I'm going to have to think about it some more, to, oh boy, there's one or two that I did kind of pick out and I'm thinking, I'm still not sure I've found a good answer for that one. So range in all sorts of complexities on these kind of prompts. I love some of you are starting to type into your text chat. And I remind you that typing in one answer doesn't mean you're done. Think back to that planning sheet. Can you get a little closer? Can you tweak it a little bit? Is there something else you could do? And I'm just realizing that my 30 minutes is going much, much faster than I expected. But I'm seeing some of the ideas that you had here. So I'm going to pull up a Jamboard real quick and just share out some of that. And I don't think I'm going to get to the final answer, but just share a little bit of some of the things that are coming through in people's strategies, and even just highlighting again, like what is our limiting, this form here limits what our answer can look like. And so we had sort of these questions of what I can put into that box because my answer can't be exactly 10. And I'm seeing lots and lots of answers where you've targeted some way of putting a 9 in that box and then are thinking about different ways to generate that 9 or to, and how big can you make this 10th spot. And so we have a lot of different strategies there. I'm going to suggest or ask that you flip through some of those answers in this chat because they're visible. And just, are there any patterns or ideas or commonalities that you're noticing in people's work? Is there something that I'm kind of finding kind of interesting? I'm going to make a note here, some of the examples that we saw. In particular, what I'm focusing in on is choices for the first add-in. I saw 27 thirds. I saw 81 ninths. I saw, yeah, Rachel, you're picking up the pattern. Go ahead and unmute and talk about it a little bit.
So what I did for the first one that I answered, I did, let's see here, I gotta scroll up because I can't remember. I did 54 ninths plus 7 halves and got 9.5. But then I realized that I could do other fractions that equal 9. So I did 81 ninths so I could rearrange my numbers a little bit so I could get a bigger decimal. And so I did 81 ninths plus 4/5, and I was able to get that 8/10.
Okay, so I think I lost that one, but tell me your final one again.
It was 81 ninths plus 4/5, so I could get 9 8/10.
Uh-oh, we got an issue though.
I know. I realized later that I used 9 twice.
Which I love. So, you know, that's what we got to think about is that's the beauty of this math, right? Like, oh, it maximizes, but I've reused digits. So I'm going to actually leave us there and say, isn't that a beautiful spot as a teacher to have a student be? Because now we're going to challenge them to think, what could you tweak? What can you play with? What equivalences can you use that you're not reusing a digit, but it still gives you an optimal answer? Okay, and I am totally blown away by the fact that it's 2:30 because I got totally engaged in doing math. So I hate to do this, but I need to share with this website and what's going on. So on the website, the link is to Open Middle, and you can just see across the top, we have kindergarten through high school mathematics problems. I was pulling from 5th and 6th grade. For example, in 5th and 6th grade, we could do, actually I was doing number and operations and fractions. And you can see there's just problem after problem. For example, adding 3 fractions and asking the students to think about fractions that would add to 1. Most of them have this open box format where we're filling in those digits 1 to 9, and we have those limitations. Some have that optimization element, and I'll pull that out here in just a second. But 5th, 6th grade, and we can just give the students that visual prompt. You know, here we've got thinking about factorization, which is a big piece in these grades. Now, I will caution you, you wouldn't want to send students directly to the site to give prompts because the answers live right under there, and that's just too much of a temptation. So you are going to want to find some way to pull out those problems to assign them. The problems that we pulled out today and these 2 additional problems are available to you in your packet and as a student-friendly prompt. You also saw quickly there I was using the JamBoard to record your thinking. But these open middle problems, they have multiple ways to enter them. You know, some people started by thinking about halves, some people started about thinking about wholes, use equivalents, you know, improve and tweak your answers. Often they have this element of optimization, so you find kind of a correct answer, but then you think about how can I improve it? And you know what, at first it's like, oh, it's just a computation problem, but it isn't. Okay, and if you guys will stick with me, I'm going to share one other resource, and I'll do this one much quicker. These are tiled area questions. It's another way to engage students in thinking about those fractional parts. In this particular problem, I'm saying that a square, this blue square, for example, is 1 whole, and I'm asking students, well, what's the area of the shape? And so I do want to give you just a few seconds to really think about that. And we'll talk through at least one example of how a student might approach that. These are available on Steve Wyborney's site. You may have seen other things there. Fractions flat is a popular one, Estimistries. And what I want to focus on here is not that the answer is 4.5. I know I didn't really even give you enough time to get there, but the conversation and the strategies that can come out. So I'm going to go ahead and again take us to a Jamboard and just sort of talk through again how this visual and how this recording might work. So the answer is 4.5 because the size of this unit is 1. But I wonder if somebody, I know I didn't give you enough time, but maybe somebody's done this before, or if you did have a chance to do it, can you share how you broke it apart? Or how you visualized it?
Cindy, it's Kelly. I can go.
Yeah, why don't you go ahead and go? That'd be good. Thank you, Kelly.
Okay, perfect. So, Cindy, I saw the upper left-hand corner, the 3/4 green box, and I saw that as 3/4, and then I added to it the blue 1/4 piece below it. So my head is thinking about making ones. Crazy enough, I didn't go straight to the full ones because I was like, those are already ones. I don't have to think about those first. So then I did the 2 reds, a red half and a red half, and I called that a 1. And so my mind said 1, 1, 1, 1, and I was adding it together in my head. 1 + 1 is 2, + 1 is 3, + 1 is 4, and then I see the little green box, which is a half in the upper right-hand corner, 4.5.
The Jamboard is part of the Google suite of documents. Somebody kind of asked if you could do that. I don't know personally about the tablet, but I do know, like, if I'm making a new Google document, one of my options is Jamboard. And I'm finding that to be a really nice platform because it does allow the drawing and it does allow putting in that picture, that prompt. And so it's become kind of one of my go-to tools now when I need to scratch and record and visualize. And another way to use that, so if I go to that Jamboard, you know, we had the one we just wrote on, so it worked well for that. In those materials from Wyborney, you do have these blank recording sheets. Those could be printed and given to students, and they intentionally have those 6 copies on there because we want students to think beyond their first thought. So, you know, Kelly even sort of made this observation of sort of, it's interesting that I went to this 3/4 and a 1/4 first, and so they can maybe play around with other ways they might visualize it in color and draw those. And so here's another example of how you might record on the Jamboard your visualization and how you chunked and saw the pieces. So I'd encourage you to check that out. It would give students, if you're assigning things digitally, it may feel like, oh, they can't draw on it and write on it. Jamboard might give you a way to do that. Of course, if you're printing these materials for students, then that becomes an option built into the resources provided. Okay, I've lost my, there we go, presentation board. So there's an example of that Jamboard. Here's an example available from the Steve Wyborney site with the student recording on there to give you a sense of how a student might approach it. Here's like some of the different ways. So it starts showing, we could have a student take it down to seeing how many fourths are in there. They might, like Kelly, compose the ones. They might create their own lines to think about really just, it's the net area. I don't need to use their way of chunking it. I can use my own way of chunking it. So you have all sorts of different strategies. These are all in the Steve Wyborney blog. And so you can click the link in the PowerPoint, it'll take you to it. He's got videos to illustrate it. He'll tell you all about it. He's got the downloads. So this is really versatile. He's got more, you know, plenty more prompts. But I want you to know that if you go check it out, we have these initial 12 pages, and they're 12 different shapes that he provided. But then if you do a search for these tile area questions, he added to it, and he added many more blanks. But for middle school, he bumped it up by really saying, okay, you got it for when it's 1, but what if that square is 4? Or what if that square is 1/2? And now we have this proportional reasoning of scaling it up. And oh goodness, how does changing what our unit is change the total area? And Chris, you're finding out how that JamBoard's available on tablets. I'm very excited about that. That is perfect. Coming back to our research, we were playing around, like you guys were using those different meanings of fractions to have strategies. You were visualizing, you were living in that measurement mode, especially on those area problems. We were thinking about the size of the piece. That fraction is naming an amount of area. And those next prompts, as we think about, what if that unit's a 4, what if that unit's a half, is going to really push that reasoning up and down. So we just got started. I appreciate you guys sticking on with me for longer than 30 minutes. It's so hard to do 30 minutes, and I failed miserably, so I appreciate you sticking around. But we have a lot more proportional reasoning work coming through the week, with Funda going to really dig into making those connections between fractions, decimals, and percents. And come join us. If you go to the KCM site, one of your links will take you to, you'll see this page, and you'll have a link that'll take you to the logins and the recordings and the printable documents for each of these sessions. So here's my contact information again. Please feel free to contact me, especially because I didn't get a chance to follow in some of the details. And also just let us know how it's going. We'd love to hear from you.
At the Kentucky Center for Mathematics, we always want to give you some food for thought and do it in a packaged way. You're right, Cindy, 30 minutes is an impossible task, and you did a great job. You did a great job, because we just don't know, during these sessions how that conversation is going to go. So thank you for having that rich conversation. One thing that I want to end with is a theme that we're going to have for this week, and that is that teachers across the nation and actually across the world now have this unique opportunity not to worry about assessment at the end of the school year. What we believe in at the Kentucky Center for Mathematics is that you really give a student a question, like the Robert Koplinski open middle question that we started with, and drop it out there for students, let them wrestle around with it, circle back to it the next day. So we want to encourage you to be part of that game changing. You have that opportunity to have students, allow them some time to think about it. What is your first attempt? What is your second attempt? Cindy, you couldn't have done it any better in giving us that kind of impetus to really change. What are some of the things that we're giving students to do at home? And how about if we say slow and easy and doing a great job digging deep? Now is the time to dig deep. We thank you so much for joining us. Appreciate when you spend time with the KCM in the afternoon. Hope to see you tomorrow afternoon. Thank you.